really be worth it, I guarantee. All right, so it looks like it's 10:01 on my clock. And so again, welcome in everyone. This is our first of a series that we're going to do throughout the year, the last Friday of each month. Bill Hall, who is our team expert, is going to walk us through a series of trainings. Today, we're going to start with Water Softeners 101, which is a basic, very basic water softening. Next month, we'll continue on then with the 201, which will be a little deeper dive. So today, even though a lot of you are experts, I guarantee you'll learn something new today. Bill has a really great presentation ready for us. And again, welcome and thanks for joining and thanks for spending the time. And all of you customers, thank you for being loyal Charger customers. We truly appreciate you. So, Bill, with that, I'm going to give you the floor.
All right. I appreciate everybody being here today. And I know this is a pretty basic topic, but I've learned through the years that the folks that know more about water treatment than anybody else are the ones that have been in the business a year or less. They've seen it all. They know it all. They've run into all the situations. I've been doing this for 40 years, and I realize that I don't know anything about water treatment. It's a very humbling industry, but we'll get through it together. And what I'm going to do is share with some of y'all some of the tricks and the rules of thumb and the stuff that I've learned through the years to help me get through this. And I will share those with you, and we can go from there. So let's get started. I mean, to start off with, first of all, where do we get our water? We're going to start right from the beginning. So the life begins with the water source. The water that we have on Earth today is the same water that's been there since the beginning of time. There's no new water. Water works in the hydrological cycle or the water cycle. The water we use today. Let's start with the cycle of the evaporation of water from the surface of the ocean. As the moist air is lifted, it cools and forms water vapor, condenses, may form as clouds. In fact, clouds are made up of tiny water droplets and ice crystals that are so small they can float in the air. The moisture in the atmosphere may be transported around the globe until it returns to the surface as precipitation. Precipitation can take the form of rain, snow, sleet, hail. Once the water reaches the ground, one of two processes may occur. Some of the water may evaporate back up to the atmosphere, or the water could permeate down through the surface and become groundwater. The groundwater can take several paths. The groundwater may seep its way into the oceans, rivers, or streams, or it may go to an aquifer, which is a body of saturated rock through which water can easily move. Or it can release back into the atmosphere through transpiration. Transpiration occurs when leaves from trees and other vegetation give off water vapor through the pores in their leaves. Some water is not absorbed by plants or becomes groundwater and it becomes surface runoff. This runoff can empty into lakes, streams, and then it's carried back to the ocean where the cycle begins over and over and over again. So there we go with the basics of the water cycle. So to review a little bit, No, I did. I wrote that. I I choreographed. I did all the. That was me in the back with the short pants. No, really. I know, right?
Good job, Bill.
Thank you. Thank you. So water.
Impressive.
Yeah. Thank you. Thank you very much. Water's the universal solvent, and no. Hang on. Hang on. Here we go. Water dissolves more minerals than any other liquid on earth. It does well on minerals. It doesn't do so well with fats and oils and that sort of thing, which tend to float on the surface of water, but it does dissolve a lot of minerals. Rainwater absorbs carbon dioxide to become slightly acidic. So for that reason, it's able to dissolve limestone, dolomite, and the like. As river water flows over rocks, it dissolves small amounts of minerals, while water percolating through the ground can dissolve more minerals. That's what causes water to be hard. Groundwater tends to be harder than surface water. So what's the problem? What's the problem with hard water? Hardness minerals prevent soap from lathering, resulting in soap scum and require more soap, detergents, and cleaners to achieve the required results. Scale due to hardness can cause increased maintenance costs due to premature failure of appliances, fittings, fixtures, and heat exchanger surfaces. Hard water causes problems with both residential and commercial industrial uses. Some conditions caused by hard water are merely unsightly and a nuisance. These can be water spots on glasses, utensils, dishware. More noticeable could be spotting and streaking of large shiny surfaces such as glass shower doors and mirrors, requiring additional attention, labor, and cleaners. Hard water can lead to dry and irritating skin, dandruff, and I'm told it can cause dry, dull, and tangly hair. I am by. All right. Clothes, towels, fabrics can be scratchy, less colorful, and gray. So besides just the nuisance problems, there's more physical problems to be caused by hard water. Similar to plaque buildup in human arteries, scale buildup in pipes and fittings can result in flow problems and increased pressure drops in plumbing systems, with extensive costs to repair. Besides nuisance problems, anytime you heat hard water or cool it, it tends to plate out on heat exchanger surfaces. This scale forms a sort of insulation around the surfaces, requiring more energy in time to heat the water as compared to what was needed when the surfaces were new and clean. This adds to increased utility costs and premature replacements. So what do we do about it? We're going to soften the water by removing the hardness ions. An ion's an atom with an electrical charge. Cations have positive charge and anions have a negative charge. So how can you remember which is which? What do cats have as opposed to hooves like horses and cows? They have paws. Therefore, it makes it easy to remember that cations, are positive. Generally, cations end in like sodium, calcium, potassium, magnesium, strontium. So cats, are positive. The two main hardness culprits are calcium and magnesium, which are both cations. So while there's more than one way to soften water, removing the hardness ions, for our purposes today, we're going to discuss ion exchange water softening. So what is ion exchange? Ion exchange, known as IX, water treatment is a process that removes dissolved contaminants, such as the hardness minerals of calcium and magnesium, by swapping them with less harmful ions like sodium or potassium, utilizing synthetic resin beads. This can be you can kind of picture this out by, let's assume that you've got a bunch of monkeys hanging in a tree, each one of them holding an apple in each hand. So what do monkeys like to eat better than apples? They like bananas. So as the bananas start falling down past the monkeys let go of the apples and grab the bananas. This is a way to think about the ion exchange softening process. The monkeys are the resin, the apples are the regenerant, in this case sodium, could be potassium, and the bananas are the calcium magnesium hardness in the raw water. Eventually, the monkeys have got hands full of bananas. They've taken out all the calcium magnesium that can flow past them, and they can't grab any more. So how do we get the monkeys to let go of the bananas and drop so many? So what we do is we drop so many apples past them that they can't help but grab the apples and let go of the bananas. Once that happens, they let go of the bananas and grab the apples. Sorry. The resin's now regenerated and ready to remove more bananas. So you got the monkeys. Think of the monkeys as the resin. Apples being the regenerant, the calcium or the sodium or the potassium, and the bananas being the hardness. So let's look at a generic cation water softener. We've got a fiberglass mineral tank, a distributor tube with a screen at the bottom, some gravel underbedding to assist in even water throw and distribution through the bed, topped by a resin bed. Control valve sits on top of the mineral tank to direct the flow of water through the bed and initiate and control the steps of regeneration. During normal service, the hard water flows down through the resin bed, becoming soft. Then through the screen and upward through the distributor tube and outward to the house. What we've got here, the monkeys are grabbing the bananas. Eventually, the monkeys have grabbed all the bananas they can hold. The resin has removed all the calcium and magnesium it can and has reached its capacity. We now need to regenerate the resin by getting the apples back into the hands of the monkeys, meaning we need to kick the calcium magnesium hardness off the resin and replace the exchange sites with the sodium ions. This is a regeneration process. The first step of regeneration is backwash. We reverse the flow by directing the raw water down through the distributor tube, out through the screen, and upwards past the gravel underbedding and through the resin bed. This fluidizes the bed by fluffing it up and getting it ready to accept the sodium chloride regenerate and get a full regeneration. Next step of regeneration is brine draw. The control valve pulls the brine solution from the brine tank by use of an inductor or an ejector. The brine solution enters the mineral tank and flows down through the resin bed, thus kicking off the bananas or the hardness ions of the calcium magnesium from the hands of the monkeys or the resin exchange sites, and puts the apples back in the hands of the monkeys or the sodium ions back onto the resin sites. Note how the resin bed changes from exhausted to regenerated from the bottom up as the water flows to the drain. Also notice the brine solution has been drawn from the brine tank before the end of the cycle. Next step of regeneration is rinse. The water flows to the drain in a downflow way to help the rinse out any excess sodium and settle the bed in preparation of going back into service. The resin's been fully regenerated at this point, and the regeneration process is complete, short of refilling the brine tank to the proper level of water in order to dissolve the proper amount of salt required for the next regeneration. Water does not flow to the drain at this point. In conclusion, we can do this over and over and over and over again, unless the resin becomes compromised in such way, such as fouled with organics, or has been degraded by chlorine or other reasons. Ion exchange can work for other constituents other than hardness as well. The procedure is similar. You just need different monkeys. That's all I got on my presentation, but I'm open for questions. Anything y'all want to ask, anything you want to go over again, anything that's bothering you, lay it on me.
Hey, Bill, you just one time you wrote an article about discharging salt and how it's really not detrimental to yards and that kind of stuff. Could you kind of touch on that?
Yeah, we there's a lot of people that will tell you that you can't dump brine discharge right out on the grass because it'll kill the grass. Well, when I lived in San Antonio, I took a 5-gallon bucket and ran my water softener discharge into the bucket. Then I had like a little giant pump in there with an automatic switch that as it got full, the pump would kick on. And I ran a short piece of garden hose with just a sprinkler, just a round sprinkler with holes in it, something with not a lot of back pressure drop. And every time went to a regeneration, it pumped the discharge out onto the grass. Now, if you think of it, you've got a brine solution, and if you were to take that brine solution, 100% brine, and dump it out on the grass, you might have a problem. But the way we pull it into the water softener is pulling through the eductor, we're diluting it to a certain point right there. Additionally, as it goes into the top of the water softener, we've got fresh water in the top of the water softener, so we dilute it again once more. As we go down through the resin bed, we're pulling even more sodium out of the water. So by the time we actually get to the discharge, we've diluted that water so much that where I put the water on my lawn, it was the greenest part of the whole yard. Now I moved the sprinkler around periodically so it wouldn't build up in one area. And also, as long as I kept it off the roses, kept it off the flowers, just put it on the grass, It works very well. So I'm not saying that's going to work in all situations. Something to keep in mind, the harder the water is, the more sodium you're going to exchange more sodium. So therefore, if you've got 100 grain per gallon water, that may not be the best thing to dump that discharge on the grass. However, my point is that it does dilute it quite a bit, and there's not nearly as much. Don't let somebody tell you that it's automatically going to kill the grass, because that's not always so.
That's good to know.
Hey, Bill,
There,
you want,
there was a
oh, I'm
there,
sorry.
no, there was a question. Crystal blue water. Oh, that's okay. Go ahead with your question.
Hi, good morning, guys.
Morning.
Uh, I had a question. So, like Bill said, it's not always the sodium would kill the grass, but what if like you use potassium, right? So if you do potassium exchange, so is potassium, can you like, drain the whole system with potassium in the grass? Is that safer than sodium or?
Potassium is certainly safer on the grass than sodium would be. There's a
Okay.
lot of people that talk about, I can't have a water softener because my doctor told me I'm on a sodium restricted diet. So therefore, I don't need to be drinking soft water because of the sodium. One thing to keep in mind is that very few of us, if we have a medical problem, have more than just one. As detrimental as sodium is to a cardiac patient, potassium could be to a kidney patient. So don't automatically assume that I'll just go to potassium chloride and take care of all the problems. You still need to trade off one for the other. But to answer your question, yes, potassium is not as detrimental on grass as sodium would be.
Right. Okay. Thank you.
Yes, sir.
And I think I heard an analogy that I kind of stuck with me, and correct me if I'm wrong here, but someone said drinking soft water when people are worried about the sodium is equivalent to one slice of bread, the sodium in one slice of bread. I thought that was a good analogy. So really, yeah, not enough to hurt the average person or affect
And
their diet.
if there's ever a problem with it, put it in an RO, an under the sink RO, and take it right out of the equation.
Mr. Hall, I got a question for you.
Yes, sir.
How would the drain water affect the septic tank, or is there an issue with draining into a septic tank?
Good question. A lot of the on-site septic tanks now, instead of using a leach field, have now got an aeration system and an aerobic system. The Texas Water Quality Association, the folks that put those things in were concerned about, they have to warranty those things for a certain amount of years. And if you start introducing a lot more water than they were expecting it to have, when they designed the system, the folks that put in the septic systems were saying, if you run soft water or water discharge into this system, we can no longer warranty it. What they came up with was a compromise that says if you take your discharge water from your softener and put it into the second tank, there's two tanks. First one's got the air, the microbes in it and that sort of thing. The second tank is your pumping chamber. Discharge your soft water discharge into the second tank, into the pumping chamber. Keep it away from the microbes and just pump it out on the grass, and you shouldn't have any problem.
Okay, gotcha. Thank you, sir.
Hey, Bill, I think also the WQA did a study a number of years ago about septic tanks and septic fields with discharge from a water softener. And they found that it really wasn't detrimental and in fact, increased the amount of bacteria in the septic tank,
There you go.
if I remember correctly.
I believe you're right.
Thank you, sir.
You bet.
Yep, go ahead.
So another question, Bill. I met with like a couple of, plumbers, right? And their philosophy is saying that supposedly on them that salt damages plumbing. And I, don't think it does. Is there is that like their philosophy? Is that like a little bit maybe 1% true, or is zero, or is it better changing to potassium and it will damage sodium less? I mean, it'll damage the plumbing less. Because that's a lot of plumbers, all they say is like, oh no, the sodium's gonna damage your plumbing, which it doesn't make sense. It's gonna help the plumbing, but is there a better potassium versus sodium? I mean, is there a benefit using potassium better for plumbing or sodium, or it's the same?
I don't believe you're going to find any difference between using potassium based water through a pipe as opposed to sodium based. Years and years ago, when all the piping used to be galvanized, there were a lot of problems. When we went to copper, not so much. Now that we've got the more inert piping systems such as PEX, there's very, very little downside to it. The bigger downside would be not having a water softener and letting the hardness played out inside the piping, reducing the diameter, the inside of the pipe. So you're trading off everything in this world. You're going to trade off one for another. There's no God's answer to the whole system. So we're trading off one for the other. My position is sodium or potassium running through your water supply is a whole lot less damaging than hard water would be.
Thank you.
Great questions, guys. Anybody else?
Next time we'll build on this a little bit more. We'll get into more meat and potatoes about how to size a water softener, what the capacities, how you configure, how many gallons of hard water you're going to get between regenerations. We'll get a little more into it. This was just kind of a basic starting point, I guess you could say. And we're going to build on it. It should get a lot more exciting later on as we go. We're going to talk about advanced water softening. We're going to talk about system design and troubleshooting. We'll be talking about RO, under the sink RO, where it works, where it doesn't work, what you need to be aware of it. We'll get into more commercial RO systems. We'll talk about how to read a water analysis. We're going to get into a lot more details later on and build and try to make everybody more comfortable with the whole process.
Hey, just a quick question for you. This should count as part of our C&E for the TWQA.
We haven't
It's
gone that
basically-
far as to.
It's basically the same subject matter.
There you go. There you go. Well, just consider this a parallel to what they're giving you credit on. Yeah. We may be able to do something along that line in the future.
Darn it.
I got
But we
another
really-
question for you.
Sorry.
I'm sorry, I got another question for you, Mr. Hall. Roughly during a regeneration cycle, how much water are we draining?
It depends. You can set these things up to where you're recovering quite a bit of water, dumping very little. Keep in mind that you've got to let the process work and do what it's trying to do. Anytime you're trying to cut back, you're going to be giving up something else. Generally, depending on how you set it up, my rule of thumb would be you're going to be using somewhere around 100 gallons, maybe as much as 200, but it depends on how you set it up. And we can tweak that in the field very easily. And I can show y'all how to do that to where you can cut down on discharging as little water as possible.
What size tank
I'm
is
sorry.
that?
Normally a 1054 or a 1252, 1.5 cubic foot to a 2 cubic foot. take a look at your, we'll get into this a little more next time, but take a look at how many gallons per minute are you running to the drain during backwash. If you've got a 2.2 gallon per minute button or a 3 gallon per minute button times how many minutes is your backwash cycle, and then how many minutes is your brine draw cycle, you can come up with a rough idea of how many gallons you're going to be discharging.
Oh,
Awesome. Thank you.
So next month, as Bill mentioned, it'll be the last Friday of each month. If there's a different email that you'd like to include, or anyone else you'd like to include in these, I can send the invite. Go ahead and put it in the chat, which is just clicking the chat button at the top, and you'll see Tony has already added one in there. Just put the email in there and I'll include them next month. We'll be sending out the same sort of link that you got this time, but I'd like to include anyone specifically that would like to be included. As Bill said, he'll go into more detail on softening, more of a 201, I think he's calling it. Again, thank you all for joining. We really appreciate you being here, and we appreciate your business and supporting Charge of Water. Our customers are the most important part of our business. So, Bill, did you have anything else you wanted to add?
Not at this time. I appreciate everybody being here. If anybody comes up with some ideas on what they would like to talk about, send me an email to bhall@chargerwater.com and give me your thoughts, and we'll see what we can do.
Fantastic. Well,
Good
everyone,
job, Bill.
have a wonderful Friday. Bill, we really appreciate you being here. This was not only informative, but entertaining as well. So thanks for the morning giggle on your graphics you've done. You did a great job. And
Thank you,
Bill.
we can't
Well
wait till
done,
next
Bill.
month.
Yeah, very good
Thanks,
job,
Bill.
Bill.